Hello, welcome to this beginner course on machine learning. My name is Ethan Parker. We are at lesson 4 today. We have talked about types of data, where it comes from and looks like, and then we talked about setting us up for success by pre-processing. Today's lecture is on Exploratory Data Analysis, commonly known as EDA. EDA is a crucial step in the data analysis process. It allows us to summarize the main characteristics of a dataset, often using visual methods. It helps us understand the data better, identify patterns, spot anomalies, and test hypotheses. Why is this important other than introducing another term and acronym? Well, it is important for a number of reasons. Remember, data is the absolute foundation of machine learning. First, EDA helps us understand the data. We gain insights into the structure and content of the dataset. Second, we identify patterns. It looks for trends, correlations, and relationships within the data. Third, EDA helps us spot anomalies, detect outliers or unusual observations that may require further investigation. We talked last time about how critical it is to have clean data. EDA is important because we must understand the data before we can choose a model for our machine learning application. Finally, EDA allows us to come up with or formulate hypotheses. This means we can generate questions and hypotheses for further analysis. There are 4 key components of EDA I want to point out. Number 1 is data collection. Before we can analyze data, we need to collect it. This can come from various sources, including databases, CSV files, APIs, and web scraping. We talked in depth about these in Lecture 2. Number 2 is data cleaning. We discussed this in Lecture 3. This includes handling missing values, removing duplicates, correcting inconsistencies, and converting data types. Number 3 is a new one, data visualization. Visualization is a powerful tool in EDA. It allows us to see the data in a more intuitive way. Common visualization techniques include the following. Histograms. Histograms are diagrams consisting of rectangles whose area is proportional to the frequency of a variable and whose width is equal to the class interval. Here is an example where a teacher, Miss Gumberbunny, is identifying the number of students who have grade falling into a range represented by the rectangle. This allows them to understand the distribution of numerical data. Box plots. This one is fun, and by fun I mean, what the heck? A box plot displays the 5-number summary of a set of data. The 5-number summary is the minimum, first quartile, median, third quartile, and maximum. So in this sample we see that in Miss Gumberbunny's 6th grade math class they took a test. Christy, who always gets the highest grade, got a 98. Danny, always low man, got a 68, which is pretty good for him. The first quartile was 78 to 85, the third 85 to 93, and the median is 85. This helps identify outliers and understand the spread of the data. How about scatter plots? A scatter plot, aka scatter chart, scatter graph, uses dots to represent values for 2 different numeric variables. In this example, there is a clear correlation between the kiddos who did their homework and the final class grades. You can see how this helps explore relationships between 2 numerical variables. Finally, heat maps. First, let me say, heat map is just one of those cool words to say. And there are all sorts of heat maps. A heat map is a 2-dimensional representation of data in which various values are represented by colors, spatial, time series, tabular, all to visualize correlations between multiple variables. And of course, the classic heat map we see for data analysis. Those are some ways to visualize data. The 4th component is descriptive statistics. Descriptive statistics is a set of brief descriptive coefficients that summarize a given dataset, representative of an entire or sample population. They provide a summary of the data, and they are broken down into key metrics or key components. You have heard these words already in the first lectures, so you should be getting used to them. These components include the mean, which is the average value, the median, which is the middle value when data is sorted, the mode, which is the most frequently occurring value, There are also measures of variability, which include standard deviation, or the measure of the amount of variation or dispersion in a set of values. There is variance. Variance is a measurement of how far each number in a dataset is from the mean, average, and thus from every other number in the set. There are others like skewness and kurtosis, but these are the main ones. Those are descriptive statistics. Let's talk now about how we use all these terms and words and graphs and plots to do exploratory data analysis. What are the steps? Step 1. Load the data. The first step in EDA is to load the dataset into your analysis environment. This can be done using libraries such as pandas in Python. Here is an example of importing using Python. Step 2. Understand the data structure. Now we use functions like the following to get an overview of the dataset. Step 3. Visualize the data. You create visualizations to explore the data further, for example, using matplotlib or Seaborn in Python. Now on to step 4. Identify relationships. Use correlation matrices and pair plots to identify relationships between variables. Finally, step 5, document your findings. As you conduct your EDA, document your findings. This will help you in the next steps of your analysis and in communicating your results to others. So, in conclusion, exploratory data analysis is a vital part of the data analysis process. I know that this lesson introduced a ton of new terms and some code even. Well, friend, if you're wanting to do machine learning, you might want to think about learning Python or another language if you haven't already. Anyway, EDA. It allows us to understand our data, identify patterns, and prepare for more complex analyses. Remember, the goal of EDA is not just to analyze the data, but to gain insights that can inform decision-making. This is an important step. Don't shortcut it. Henry Wadsworth Longfellow correctly wrote, "It takes less time to do a thing right than it does to explain why you did it wrong." Cheers and have a blessed day. Please like and subscribe for the sake of Tech Skill Hub and all the typing the big guy did to make this possible. This is Ethan signing off.